So I decided to put this video up because we had a couple of students out and I figured it would be easier for them to catch up if they could watch the notes and watch the video and take the notes and hopefully sort of stay up to speed with where we are. So I am on this page in your notes packet, and last night you should have completed the review of basic inequalities. And I'm going to try and post that answer key to Edmodo as well, and that way you'll be able to review and make sure you're okay with the solving compound inequalities. So we're talking about absolute value inequalities, and if you think back to when we did absolute value equations, we talked about what that really means in words. And what that really means in words is the distance between x and 0 is less than 2. Before we had an equals, and we said the distance between x, if it was the absolute value of x equals 2, we said the distance between x and 0 is 2. Now we're saying it's less than 2. So what does that mean? It means that graphically, the distance between my number and 0 has to be less than 2. So as a graph, I'm going to put my circles down here this time. It's going to look like that. Okay, I can't include -2 or 2, but anything in between is going to keep the distance from being under 2. Symbolically, x is between -2 and 2 exclusive. If we go back to our set terminology. Alrighty, so this one then is going to say something a little different. The absolute value of x minus 3 is greater than 4. So in words, really think about what that is saying. The distance between x and 3 is greater than 4. So the distance between the number that I want to choose and 3 has to be greater than 4. So here's 4 units away from 3. I want to be going in that direction. I want all these numbers included. And in this direction, I want all these numbers included. So graphically, that's going to look like an open circle going down from 0 and an open circle going up from 7. Symbolically, that's x is less than, oh, did I count that wrong? Sorry, guys. Yeah, sorry about that. I can't count on a number line. That was a -1. Sorry about that. Got to move this guy down now, too. There we go. All right, so x is less than -1 or x is greater than 7. So I think you have a little thing on your page that says either, and what that means is either x minus 3 is greater than 4, in which case you get x is greater than 7, which we have, or, now remember when I talked about this initially and we had the absolute value of x minus 2 equals 7 or something, and I said you're going to break that out into 2 cases and you're going to have x minus 2 equals 7, or the opposite of x minus 2 equals 7. And our shortcut was we just said either x minus 2 equals 7 here or x minus 2 equals -7 here. And the reason we could do that was because we were just taking this negative and moving it to the other side by multiplying both sides by -1. But if you think about absolute value and an inequality versus an equals, when you multiply through an inequality by -1, you have to flip the symbol. So this is saying the opposite of x minus 3 is, what problem am I doing here? Here we go, greater than 4. So to move this, to multiply both sides by -1, I would have to change that and say less than -4. Okay, so I would get x is less than -1, which is what you saw over to the side. The alternate way of doing this would be to say -x plus 3 is greater than 4. I get -x is greater than 1. And then I would multiply through by -1 or divide through by -1, and it would be x. Either way, I'm still getting that -1. So let's try an example here. The next one, example 1, says the distance between x and -5 is less than or equal to 8. So what's that going to look like from a procedural standpoint, I'm going to have x plus 5 is less than or equal to 8, and I'm going to have the opposite of x plus 5 is less than or equal to 8. So this is going to give me x is less than or equal to 3, and I'm going to move the negative to the other side just because I feel like it. And I want to keep my x positive, so I'm going to get greater than or equal to negative 8. I multiplied through this whole entire thing, essentially, by negative 1. Okay? So I have to flip the symbol when I multiply through an inequality by a negative. And then I'm going to get x is greater than or equal to negative 13. And if you think about this, okay, here's negative 13. Here is 3. And it's greater than or equal to negative 13. So I use a solid circle here. What I'm talking about is I want to be less than 8 units away from negative 5. Does that kind of check here? Well, between 5 and negative 13, sorry, my little bracket's weird, it is negative, it's 8 units. And this is also 8 units. So I'm less than or equal to 8 units away from negative 5. Sort of makes sense? So try number 2 on your own, pause the video, and come back and look at my solution. So I have x minus 4 is greater than 3. X minus 4 is opposite of x minus 4 is greater than 3. That's going to give me x is greater than 7. And x minus 4 is less than negative 3, which gives me x is less than 1. Okay? And okay, so I'm going to graph that, greater than 7, less than 1, and open circles. And if that makes sense, the distance between x and 4 is greater than 3. Well, this distance right here is 3. And this distance right here is 3. And I want my distance to be greater than that. So it checks. All right, take a look at number 3 and number 4. Try them on your own and come back and check the solutions. So for number 3, I would get x plus 3 is greater than or equal to 9, or the opposite of x plus 3 is greater than or equal to 9, which is going to give me x plus 3 is less than or equal to negative 9, and x is less than or equal to negative 12, and here I would have x is greater than or equal to 6, and so I'm going to have negative 12 and 6 on my number line. I am going to use closed circles and pointing this way. And that's saying the distance between negative 3 and my number is going to be greater than 9. Well, this distance is 9, and this distance is 9. So it does make sense. In number 4, kind of interesting problem. You might have gotten stumped there, but it's going to be the case that x minus 5 is greater than 0, or x minus 5, the opposite of x minus 5, is greater than 0. So I get x is greater than 5, and x minus 5 is greater than, we don't have a negative 0, so I'll just put 0. So x is greater than 5. X is greater than 5, and x is greater than 5. Well, you multiplied through by a negative here. Sorry about that. That's my bad. That's my mistake. 0 can't be negative, but that would still change because I'm multiplying through by the negative 1. So x is less than 5. And it's true. This is just saying the distance between my number and 5 is more than 0. Whoops. I don't know why that happened. I'll just move that in a second. Okay, so this should be like, oops, nothing moved with me. You kind of get the idea. All right, everything but 5. So that's basically how to solve these. The back is your homework, and I will try to post an answer key to solving compound inequalities up there for you so you can check last night's homework as well. See you tomorrow. Have a great night.